All right, thank you very much for having me today. I'm really excited to talk to everyone about how FHIR is playing a really integral role to the work that we're doing at Mayo Clinic in our Cure, Connect, and Transform strategy. A little bit about me. I'm a senior IT manager at Mayo Clinic. I've been at Mayo for 22 years. I've had various roles in our IT organization, working on our electronic health record system, and played various roles in the data lifecycle, data integration, data migration, data management. And most recently, within the last 5 years, I've transitioned to supporting our Mayo Clinic Cloud program, which is an integral part of what I'm going to talk about with our FHIR strategy. Now I have to advance both slides here. All right. So a little bit about Mayo Clinic and who we are. Our primary values, our mission, our vision, all center around patients and the needs of the patient coming first, inspiring hope and promoting health through our integrated clinical practice, education and research, and transforming medicine to connect and cure as the global authority in the care of serious or complex diseases. We are a not-for-profit organization. We serve 1.3 million patients every year, and people come to Mayo Clinic from all 50 states and across 140 different countries. We invest $500 million in research annually. We have 3 primary locations, the primary location being in Rochester, Minnesota, also a site in Scottsdale, Arizona, and Jacksonville, Florida, and 39 communities across the Midwest, primarily Minnesota, Wisconsin, and Iowa. So I mentioned earlier our 2030 vision to cure, connect, and transform. We launched our 2030 strategy in 2020. And our leadership really recognized that healthcare has operated in an environment where people being served have the least control. Technology, data-driven knowledge, and consumerism will establish the next generation of healthcare. To thrive in this environment, organizations must break through these old paradigms, understand the shifting market, and seize the opportunities to transform healthcare on the behalf of patients. The Mayo Clinic Cloud program is the physical embodiment of this 10-year strategic partnership between Mayo and Google to redefine how healthcare is delivered and accelerate the pace of healthcare innovation through digital technologies. MCC is responsible for building out Mayo Clinic's next generation of data, artificial intelligence, and digital platforms using Google's cloud-based technologies. It's composed of domain-specific subprograms that closely collaborate to build and support a cohesive and integrated set of data, analytic, and software infrastructure and services. Central to this strategy, of course, is FHIR. We are building out what's called our longitudinal patient record using Google's healthcare API technologies and FHIR R4. So a little bit of history about where we're at with our FHIR journey at Mayo Clinic. We are not new to FHIR. We've been leveraging FHIR for the last 8 years. We launched our DSTU3 suite of APIs back in 2017. This consisted of 20 FHIR resources that provided FHIR data to 25 clinical applications. I'll mention here also that we've primarily used FHIR at Mayo to integrate our own systems internally. So we have developed this kind of central repository of data and APIs to help build clinical applications, AI, and analytic use cases. So our DSTU resources serviced 46,000 API calls per week. In 2018, we launched our STU3 APIs. That was 28 FHIR resources that provided FHIR data to roughly 40 clinical applications, and that was 47 million API calls a week. Some of these applications were critical patient care applications that are used for taking care of some of our sickest patients. In 2021, we launched FHIR R4 using our Google Healthcare platform. We have 39 FHIR resources live in production today. We're providing FHIR data for clinical application development, analytics, AI, and today we have roughly 3.5 million API calls per week. We are in the process of retiring our STU3 resources and migrating all of our customers over to FHIR R4, which we anticipate to be complete by the end of this year. Here are some stats about our current FHIR R4 environment. We have roughly 11 million patients, 108 million diagnoses, 400 million lab results, 110 million medications. I'll point out some figures here specifically regarding our imaging data. I know the previous speaker spoke a lot about imaging and DICOM, and we're doing a lot of similar things in our longitudinal patient record with DICOM. Our FHIR store is truly a multimodal data source. So we're bringing data in from our EHR, from our on-premise imaging systems, from our document systems, also integrating some of our legacy EHR data that is in some of our previous EHR systems. We have close to 8 billion images stored in our Google Cloud, and we're representing all of those images through FHIR using the image study resource. It's really powerful for our customers to have a one-stop shop in one common semantic to get all of their imaging data associated with a patient cohort for a research study or for an AI model development. So this has truly been a game changer for us by way of what we can provide from an analytics perspective for our customers. A couple of additional figures here. We have 4.5 billion observations in our FHIR store and 5.5 billion provenance records. And we continue to backload and reconcile more and more data into our LPR every single day. I mentioned earlier, we're also bringing in all of our legacy EHR data. So this is just a representation of all of the live data that we've been capturing over the last 5 years. But we have 10 plus, probably closer to 20 plus years of legacy EHR data that we are going to be representing in our FHIR server as well. All right, so let's talk a little bit about how this is made possible and how FHIR is really transforming our data-centric organization. So I mentioned before, we're very tightly connected with the Google Healthcare API, leveraging the Healthcare API as a secure, compliant, fully managed service for ingesting, transforming, and storing our healthcare data in FHIR. HL7v2, DICOM formats, structured, unstructured text, which really enables the delivery of real-time clinical data for these patient care applications and for analytic use cases. So this is enabling real-time decision-making rather than retrospective decision-making. We have a persistent store of FHIR data, again, that really enables our customers, our researchers to query our LPR real-time, get real-time insights, build dashboards, reports, AI models, with real-time data from these clinical systems, clinical applications that are supporting our patients real-time. This is not an easy process. We spend a significant amount of time in the transformation and reconciliation of this data into the FHIR format. So we are receiving real-time triggers from these systems, from our EHR system, imaging systems, document sources, legacy systems as well. And then there's a process here that's rather resource intensive to identify those message types, process them, extract the values. We have mapping and configuration, data flow jobs that sit in between our data and our FHIR store, our data sources and our FHIR store to reconcile this data into, convert those data elements into the JSON objects and into our FHIR R4 schema. We then have a reconciliation process to confirm that JSON represents the newer data than what is currently in the FHIR store. And then we do the work of actually loading those resources into the FHIR store. A couple of questions I know have come up in the past about what we're using for mapping. I know there are several off-the-shelf commercial products that can be used for mapping HL7 data specifically to FHIR. We are not using any of those. We are doing all of that custom work, and we really rely on subject matter experts, data experts across Mayo Clinic, clinical experts, to do all that mapping. So it's a pretty resource-intensive activity. We also do a lot of work to define the specifications, understand which data elements need to be mapped, which data elements are most important to our consumers. Again, we have a wide variety of consumers looking to use this data for building clinical applications or AI models. We often, are approached because a customer is interested in a specific data element that we have not yet mapped into our FHIR store. So there's quite a bit of ongoing work to ensure that we're meeting all of our customers' needs. With that, that's my last slide. I want to thank everyone for the time today to share the exciting things that Mayo Clinic is doing with healthcare and FHIR. Any questions? Yes.
Oh, one sec.
Hi, thanks. I really enjoyed your talk. Given the huge volumes of data that you have under management, for use cases like AI and analytics, are you querying the FHIR repository directly, or are you using like a big data analytics engine downstream to do that work?
Right. So inherent to the Google Healthcare API suite of technologies is the ability to write your FHIR data directly to BigQuery. So all of our FHIR data is represented in BigQuery as well. So a lot of our analytics and AI use cases are driven directly off of BigQuery.
Any other questions?
Yeah, I was wondering if you could go into a bit more detail on the mapping process. And like you said that you rely on subject matter experts and that you decided not to take any of the kind of off-the-shelf solutions. So yeah, if you could just provide a few more details on that, appreciate it.
Yeah, so when we first embarked on this journey, we had an STU3. As I mentioned, we were leveraging STU3. So we had already done quite a bit of that mapping. You've got to take the HL7 data elements that are made available to us. So we pick them all up off of our enterprise service bus, ships all that data to us real time. But all of those data elements, similar to the example that you provided, right, where all of those data elements need to be mapped to a corresponding FHIR field, right? And some of them are very straightforward. Accession number, I think, is the example that you had used in your presentation. Very straightforward. But some of those coded concepts, some of those other terminology things are not as straightforward. And we really rely on, again, subject matter expertise, informatics, lots of different resources across our organization that may have more in-depth understanding of that data model and how that data is used and interpreted to make sure that we're representing that correctly in the FHIR server. So it's less of a technical responsibility and more of the responsibility of analysts and informatics and those data experts across our organization.
Thanks for the presentation. Do you think in the future the HL7 source maybe will go away and you'll have a source like FHIR messages and maybe the mapping will go away?
Potentially, yes. So our EHR is Epic. We converted we had a couple of different EHRs in place prior to 2017. And then in 2017, we went live across all of our sites with the Epic system. We do leverage the Epic APIs as well. But really, I think, to date, the HL7 data has provided what we need. We have had conversations with the Epic about the richness of the data that we're able to get from the HL7 messages and whether or not FHIR would potentially be a good replacement for that. We tend to leverage those Epic APIs only when what we're providing in our MCC longitudinal patient record does not meet the needs of all of these other systems across our organization. But the potential is absolutely there.
Since you've got a pretty phenomenal amount of data in BigQuery at this point, what kinds of analytics are you able to extract out of it?
Yeah, so we're doing as much as analytics as we possibly can using the data that we are able to extract from these systems. We developed a number of COVID reports, for example, in the early 2020s that were specifically driven off of the data that was made available out of the Epic system. One of the challenges, full transparency, that we do have is, again, to the earlier question, the richness of the HL7 data and our ability to get the level of detail of data that is really needed to drive a lot of the analytic use cases from our HL7 messages. In some cases, we have to reach into other data systems, other data repositories to get that kind of information. So we are very much limited by what these source systems are able to provide to us and the timeliness in which they're able to provide it to us as well. I think Didamia is here as well. Is she? Yes, Didamia. Yes. So I'll put a plug in. Didamia is giving a presentation tomorrow about how all of this data that we're putting into our Google Cloud platform is being leveraged for AI use cases, LLMs, generative AI, all of these analytic use cases.
Any other questions? Okay, well, thank you very much.